Welcome to qnawire.
Okay, we've got a couple compounds here that we need to compare. On the left, and on the right. And the question is, are these the same? Enantiomers, diastereomers, constitutional isomers, not isomeric. Okay, and that's 1 and 2. And then give the names. Okay, so the easiest way to do this is just like, well, do these have the same connectivity? So I see CH3, CHCl, CH3Cl. Okay, CH3, CHCl, CH, C, yes, CHCl, CH3, right? So these carbons are equivalent, and these carbons are equivalent, right? It's kind of tricky the way they did that, but there you go. Okay. So then, we could reorient these such that maybe it'll be obvious if it's simply, one's R and one's S right off the bat. But the best way is, since we're going to have to give the names eventually, we need to figure out the stereochemistry of each of these groups here. So how do we do that? Well, we rank everything. So I'm going to start on the leftmost carbon. Chlorine's the highest priority. Next is this carbon, which is attached to a chlorine. Then this is carbon, which is attached only to carbons or hydrogens, and then it's hydrogen. Okay, and then I connect 1 to 2 to 3. That's counterclockwise. And when our lowest priority substituent is in the front or anywhere but the back, counterchlockwise will correspond to R. So we know we're R on the left here. And we'll do the same thing for the other carbon. Okay, chlorine's the highest priority. Oops. Different color. Chlorine is the highest priority. After that is this other carbon, which is attached to a chlorine. Then is the methyl group. Then is the hydrogen. And we go 1, 2, 3. That's clockwise. And the highest priority substituent is in the back, and lowest priority substituent is in the back, which means clockwise corresponds to R. So on the left, we have R, 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 R. Okay, what do we got on the right? Okay, chlorine's the highest priority substituent. Next is the carbon attached to chlorine. Then is the methyl group. Lowest priority substituent is hydrogen. We go 1, 2, 3. That's clockwise, but the lowest priority substituent is not in the back. It's in the plane of the page, which means clockwise corresponds to S. Let's do the other carbon. What do we got here? Right, chlorine is the highest priority. Carbon with chlorine is the second highest priority. Then the methyl group. Then hydrogen in the back is the lowest priority. 1 to 2 to 3 is in the counterclockwise direction. Right, and when the lowest priority substituent is in the back, counterclockwise corresponds to S. So on the right, we have SS. Okay, so what are these? Are they enantiomers, diastereomers, right? Well, these are enantiomers. How do I know they're enantiomers? Because to move from one to the other, we have swapped R to S and R to S, right? So whenever we do a clean swap like that, then we know that we've got enantiomers. The only exception to that would be if we had, for example, RS and we went to SR. These would actually contain internal planes of symmetry. In this particular case, this isn't always true, but in this particular case, the RS and SR forms are actually identical because they would contain a mirror plane of symmetry. That's not the case here, though. Just pointing that out, right? So in this case, these are enantiomers. Okay. And compound 1, let's name it. I'm going to leave out the hydrogens. Okay, so what do we have? We have a 4-carbon chain, right? 1, 2, 3, 4. Or we could say 1, 2, 3, 4. Doesn't matter. In either case, we're going to get 2,3-dichloro, right? So it's 2,3-dichlorobutane. And we've got to specify that it's RR. So that's 2R, 3R. 2R, 3R, and parenthesis, dash 2, 3 dash dichloro, and then it's a 4-carbon chain, so that is butane. It's a very big U, but that is a U. Okay, and that was number 1. Number 2 is the same thing, but it's going to be 2S, 3S. 2S, 3S, 2, 3 dichlorobutane.